Hello students, welcome to TES Educations. Today we will solve some problems which is including exercise 1.1 in your class textbook. Okay na? The first question is 0 a rational number? Can you write it in the form P by Q where P and Q are integers and the condition is Q is not equals to 0. So we already know about this condition. Q is not equals to 0. When we are writing the rational number in the form of P by Q, the Q is not equals to 0, but we need to write it as the rational number. So suppose if you take 0, so we don't want Q is 0, but we can make it as a numerator, right? Then 0 by 3 or else 0 by 4 or else 0 by 5, so etc. So we can write it as in P by Q form. Okay, understand? So now let us solve second question. Now the second question. Find 6 rational numbers between 3 and 4. So we already in previous video we have seen that how to calculate rational numbers and how to find rational numbers between 3 and 4. So we know there are infinity rational numbers between any two numbers. Okay. Ikkada they mentioned that we need to find 6 rational numbers. Okay. We know the formula, average formula r plus s by 2. This is the one method to find the any rational number between 3 and 4, and another method is first we need to add these two numbers. Okay, that means r plus s. How much? 3 plus 4 equals to 7. Make it as denominator. Okay, 7 as the denominator. Now if you mention something in numerator, if you cancel them, okay, if you divide them, you need to get answer is 3. Then you can mention is 21. Now you can put this as 3, right? 7 ones are 7 threes are, so you can write it as 3. That means 3 you can write in the form of P by Q as the 21 by 7. Okay, so for the 4 also we need to write for 4 equals to 7. So how much we can write there? 28. 7 fours were 28. So we can write these numbers as the 21 by 7 and 28 by 7. So mention this 21 by 7 and 28 by 7. So we can make between these numbers as the rational numbers like 22 by 7, 23 by 7, 24 by 7, 25 by 7 and so on. Okay. So we can find out the rational numbers between 3 and 4. Now we will solve the next question. The next question is find 5 rational numbers between 3 by 5 and 4 by 5. So if we need to do the problem with using average formula r plus s by 2 for the simple integers is it is easy. For these rational numbers and the fractions we need to do lot of calculation, so we can do it easily. Okay, so here we know r equals to 3 by 5 and s equals to 4 by 5. So we already knows in the previous we need to make it as simply. So if we take the sum number, it will be, if we cancel them, we need to get this one. So we can write this as 30 by 50. If we cancel this 0 0, we get 3 by 5, right? And also for this we can write as 40 by 50. If we cancel 0 0, we get 4 by 5. So now we need to write the rational numbers between 30 by 5 and 40 by 5. So now we write 30 by 50, 31 by 50, 32 by 50, 33 by 50, 34 by 50 and so on up to 40 by 50. Okay, so we have found the 5 rational numbers between 3 by 5 and the 4 by 5. Now the next question is find the below statements are true or false. So first statement, every natural number is a whole number. Is it true or false? Is it absolutely true? Because Whole number starts with 0, 1, 2, 3 and so on. Natural number starts with 1, 2, 3. So all the natural numbers contains the whole numbers, because that's why it is true. Second statement, every integer is a whole number. Every integer is a whole number. So is it true or false? It is false, because integer numbers we know it has minus numbers, I mean it has negative numbers and also positive numbers, but whole number starts with from 0. Okay, so we are missing these numbers, negative numbers, that's why it is false. Next statement, every rational number is a whole number. Every rational number is a whole number. Rational number means it is in the form of p by q. Whole number means it is start from 0 and so on. Okay, if we take that 3 by 2, it is the whole number? No. Okay, so that's why it is false. Okay, so now we have completed the whole exercise 1.1 from the textbook. Okay, so in next video we will see the new concepts. Okay, thank you.